Okay guys, I wanted to make a video showing you why I think there is a problem with your mask, the CM6M mask. You can see the intake valve there and how it has a travel, see how it wobbles and then it travels towards the face, creating a gap here. It seems to me this was kind of designed to present the least effort possible for inhaling air. Same thing about the valve in here. It's just a huge gap there because it works with the same principle. The valves are the same, and over there you can clearly see how, without me pushing it, the valve travels, the membrane travels and creates a huge gap, and it's also wobbling there. Now I want to compare that valve with other valves in the industry because I happen to have several masks. I just got this 3M mask here, but they work under the same principle. All the membranes, they push against a retaining fixture. This is CVS. The three valves are the same, they're just positioned in different ways. But here you have it. Valve pushing against the fixture. No matter what you move it or how you breathe it, the natural position of the membrane is to be touching or closing, in this case the valve, by touching its retaining fixture. These two were taken from my Scott's ProMask 40 mask. They are removable. Good point in there, good for them. But same principle. Valve is touching the fixture, sealing the intake. Valve, it's a natural position. No matter what I do with it, it won't be moving. And I will show you in a minute why is that important. Now, also same thing, 3M. They also have something similar for you. They had some sort of similar approach. See, these valves are almost the same material as yours, but they are not wobbling. They are retained against the nose cup material using this little three prongs here, but they are removable, all these membranes, so you can achieve this same thing. You can have a membrane that is pushed against its retaining fixture, no problem, it can be done. But in yours, oh, by the way, and the 3M FF is just using the same valves, both in the nose cup. Let me show you. The nose cup, I'm trying to use a hand, are the same style, both of them, the intake ones, and the other one is somewhere there, down there. Oh well, you can see it here. It's the same valve as this one. This comes from a 7502. So it's the same type of valve here, touching against the fixture. So the standard for the industry is to have valves that will work, that will close. But when you have this valve advancing, every time you breathe, it moves. So not all the time the movement will be horizontal like this. Sometimes because the pressure in the air while you're inhaling or exhaling is not the same around the valve all the time. You can have this, the valve advancing like this and moving, not straight when you are breathing, because it's moving. And it's the same with both valves. This is a wobbling disaster, because sometimes the valve relies on advancing straight, so you can at the end having it touch the whole sealing surface of the fixture. This valve is traveling through the steam here and the steam's head, so there's a chance for it, and it's not even tightly fitting there. If the hole in the membrane was a little bit smaller, maybe this will help, but again, it could be stopped in midway. I think it was designed to do this freely, to present the least resistance to the air inhaling, but it just has no sense. I mean, there is not much effort needed to get the air moving or bending these valves. It doesn't require effort at all. Why would you want this valve to be wobbling? It makes no sense for me. It can represent a problem if in the process of moving forward and backwards, if the membrane does this because of the air is pushing, because of the air is pushing in different ways, because the pressure is not advancing in the same direction. So when the valve is there to prevent air from this cavity here, this area, to go into this area, because when it's entering is dry, but when it is coming out of our mouths, then it has humidity, and this humidity may cause this fogging inside. So that's why they are there. They are there to prevent this our CO2 from being rebreathed, so it will go down to the valve, the exhale valve. But it also is there to prevent fogging here. But this wobbling will promote a bad positioning of the membrane against the fixture, and it will allow some air to escape if the seal is not properly formed and going into the visor polycarbonate. This may be a nuisance and not a danger at all, but what I'm thinking about is the other membrane here, the one in the intake valve coming from the filter, this one here. Because the same problem happens here, is wobbling. So if while I am exhaling, this valve is not creating a good fit, a good seal, if the seal is not formed properly, then some of my air will go into the filter. And this air is not dry, it has humidity. And then the filter may acquire this humidity and keep it, which will eventually create mold. So I'm just wondering, why would you do this? Believe me, if it was with the idea of creating the least effort possible for breathing, it's not helping a lot, because to defeat the force that's putting the membrane against this fixture in this type of valve, for example, is very, very little. I just think this is a quality problem, and it's so easy to fix. Just make this steam a little bit smaller. like 3M does. See, this is how things are done. If you want to go with the steam approach and on the membrane that is round with a hole in the middle, this is the way to go. If you don't want to redesign your valves, it's okay. But this steam has no reason to be that long, creating this wobbling disaster. See? This is a wobbling disaster. This is manufacturer engineering. This is industry standard. But this is subpar. It's not really what I was expecting. So that's why what I wanted you to see. Please let me know your opinions and tell me how can we fix this, because I'm not feeling comfortable using a mask like this with these valves. Because there is a reason why they are there, why these valves are there, and I don't think these valves are fulfilling that purpose. This design of valves are fulfilling that purpose of preventing the backflow of air. These do, and of course 3M does. See? But yours are not. So let me know your thoughts.